All right, hello all. I wanted to make a quick video to help with average rate of change, to help with this topic in your homework too in Alex. Okay, so average rate of change of a function. Okay, rate of change. This word you're going to see a lot, especially when you get to calculus. Rate of change means slope. When you see rate of change, that's what I want you to think. Average rate of change, this means the average slope of a function from x equals x1 to x equals x2. We're finding average slope between two x values. Um, in the end, average slope is a slope. So to find the average rate of change, we're really just going to use the slope formula. Hopefully that programming is still in there. The slope formula is y2 minus y1 over x2 minus x1. Now, the kind of odd thing about average rate of change questions is that you'll have your x values and you'll know what x1 and x2 are. But it's not going to be obvious what y1 and y2 are. They won't just be given to you in most cases. So you're going to have to figure out what y1 and y2 are. If you see in Alex or in textbooks, they always write the average rate of change as this formula, which is f of x1 minus f of x2 minus f of x1 all over x2 minus x1. But this really is the exact same thing as your slope formula, because if you plug x2 into your function f, you're going to get y2 out. And if you plug x1 into your function, you're going to get y1 out. So this formula is really just trying to help you figure out how to find y1 and y2. But I find that using f of x2 minus f of x1 over x2 minus x1 overcomplicates things and confuses people. So I'm going to advise you for average rate of change, just think rate of change, that's a slope. I'm going to use my slope formula. And then you'll know x1 and x2, and you'll just have to ask yourself how to find a y value that corresponds to an x value. So we'll go through that in just a minute. Another thing that I want to mention here that are going to help you with the interpretation when you have a context involved is that the units of average rate of change are going to be the units of y, so whatever units y is in, per single unit of x. So it'll be the single unit that x is in. So let's say y represents a distance in miles and x represents time in minutes. Then the units would be units of y, which is miles, per unit of x, which is hour. So your units would be miles per hour. Um, and I think those units really will help you um, figure out what the number that comes out of this formula means. I think that's super helpful. So it's units of y per unit of x. You just have to figure out what x and y represent and what their units are for that. Okay, so let's start with number one here. Given the function f of x equals x squared minus 1, we want the average rate of change over the interval from -2 to 0. Okay, this one does not have a context, which means we won't have units, and that's okay. But we're still going to have to figure out how to use the formula. So average rate of change, that means an average slope. That means I'm going to use the slope formula. Now, this interval, the interval from -2 to 0, what this is saying is that this is the interval from x equals -2 to x equals 0. This is an interval for x values. Because x starts at -2, that's going to be our x1 value. And because x ends at 0, that's going to be our x2 value. Wherever x starts and ends, those are x1 and x2 respectively. Okay, so we want the average slope of this function from x1 equals -2 to x2 equals 0. Okay, so I know that x1 equals -2 and x2 equals 0. Now to find my slope, I need y1 and y2. So we got to figure out how to get y1 and y2. Okay, so x1 is -2. I can get y1 from this by finding the y value that's related to x1. So if x is -2, what's y? Well, the way I'm going to find that is my function right here. If x is -2, I'm going to find y by plugging -2 into my function. So if I take -2 and plug it into my function, I'm going to get -2 squared minus 1. And evaluating that, I get 4 minus 1, which is 3. This tells me that I have the ordered pair x equals -2 and y equals 3. Okay, we're going to do this again. Y2. To find y2, I need the y value that is related to x2 equals 0. To find the y value when x is 0, I'm going to plug 0 in. So I'm going to get 0 squared minus 1. 0 squared is 0. Minus 1 is -1. That means the ordered pair x equals 0, y equals -1 is on my function. So now the average rate of change over this interval is going to be the slope between these 2 points. We know how to find the slope between 2 points. That's going to be y2, which here is -1, minus y1, which is 3, all over x2, which is 0, minus x1, which is -2. This is just the slope formula. Now we're going to fight through the arithmetic. -1 minus 3 is -4. 0 minus a -2, that's 0 plus 2, which is 2. -4 divided by 2 is -2. This is your average rate of change. It's just the slope. So what this means is that from x equals -2 to x equals 0 over this interval, our slope on average is -2. That means on average, y was decreasing by 2 units for every 1 unit increase in x. So if x goes up by 1, y goes down by 2, on average from -2 to 0. Okay, so that's how to use the average rate of change formula. Let's try one with a context. All right, the given graph here shows the blood alcohol content in percentage for an individual over a 9-hour period. Determine the average rate of change, that means average slope, of blood alcohol level over the given interval. And then we need to interpret the results. This is where units are going to be super helpful. Um, All right, so let's just start with this. So first we have to find the average rate of change, then we have to interpret it. So let's just start with the finding part. Part A, we want to find the average rate of change, that means average slope, from x1 equals 0 to x, that should be a 2, x2 equals 1. All right, so x1 equals 0 and x2 equals 1. All right, I have to find y1 and y2. To find y1, I have to figure out what y is when x equals 0. So if x equals 0, what is y? Let's see. I don't have a function to plug into here. The only information I have about our function is this graph. So I'm going to have to use this graph to figure out what y is when x is 0. Okay, so when x is 0, the point on my graph is right here. That means when x is 0, y is also 0. So that means y1 is 0. And here x2 equals 1. So y2 is going to be the y value that's related to x equals 1. So when x equals 1, the point on my graph is right here. So when x equals 1, y is 0.06. Okay, so now to find the average rate of change or the average slope, I'm going to find the slope between these 2 points. And this is slope formula. We've got this y2 minus y1 over x2 minus x1. Now doing the arithmetic, 0.06 on top divided by 1 on the bottom. Anything divided by 1 is itself. So 0.06 is my average rate of change. Now we have to interpret the results and figure out what this 0.06 even means. Okay, units. I said units were going to help us here. So the units of this thing are going to be the units of y per unit of x. So what are my units of y? You can either read the statement of the problem, or we can look at our graph here. I think the graph is helpful. This thing here tells us what Y is. Y is our blood alcohol content in percentage. That means that the units of Y is percent. And again, I'm just going to kind of label this for you so that this makes sense. Percent, this is the units of Y. And then per, and now we need per unit of x. The units of x, again, you can read the problem, or right here on our graph tells us what x represents. X represents the time in hours, so the singular unit of x is going to be an hour. And I'm just going to label this for you as unit of x. So again, to find our units here, it's going to be the units of y per unit of x. Here it's percentage per hour. Okay, so interpreting this result, 0.06% per hour. This tells us how y is changing for each unit of x. So y, which means the person's blood alcohol content, that is what y represents. So y, the individual's blood alcohol content was changing. And here, since our slope is positive, that means we're increasing. So the individual's blood alcohol content increased by 0.06% per hour on average from hour 0 to hour 1. I'm just taking x equals 0 to x equals 1, and I'm turning it into a context. Since our x represents time in hours, x equals 0 is hour 0, x equals 1 is hour 1. So y increased by our average rate of change from x1 to x2. We just put that into English. The individual's blood alcohol content increased by 0.06% per hour on average from hour 1 to hour 0. All right, let's try to do this one more time. What if I wanted to do this between hours 1 and 2? Hour 1 here, that's x1, and hour 2 here, that is x2. So we will just rock right along here. X1 is 1 and x2 is 2. So if x1 is 1, then y1 is the is the y value that goes with x equals 1. Again, this point right here tells us that. And y is 0.06 when x is 1. And y2 is going to be our y value when x equals 2. We'll come to our graph. This is the point that's going to tell us that. When x equals 2, y is 0.09. Now we'll find our average rate of change. That's our slope. So we will pop this into y2 minus y1 all over x2 minus x1 and do the arithmetic. So 0.09 minus 0.06 is 0.03. 2 minus 1 is 1. And 0.03 divided by 1 is itself. And again, our units are percent per hour. So that means that y was changing by 0.03% per hour from hour 1 to hour 2. So y, which is the person's blood alcohol content, it was changing, and since it's positive, we are increasing by 0.03% per hour on average from hour 1 to hour 2. All right, that is average rate of change. It's just the slope formula. And if you have to interpret what you get out of that, use units to help you. I think they're very helpful in figuring out what those numbers mean. All right, I hope this was helpful for average rate of change. Happy Alexing, and I will see you in class. Have a great day.